Okay, Assalamualaikum everyone. So we will start with recitation of Kitab Al-Fatihah. First, look in front of you now. So that is the plan that we will do today. So I will brief you for a while what we will do, and then we do the experiment. I mean, a virtual experiment. Your lab report will be based on what you will see today. Okay, it might be different than what inside your lab manual. Okay, especially for example, let's say in lab manual they said use 10 gram, but during the experiment, virtual experiment later on, I will use 3 gram or 5 gram. So you need to reflect that in your lab report. Okay, your lab report based on what you see today. Okay, first today we will learn about the experiment 1C. Experiment 1C here. Where is it? Okay, experiment 1C, and also together with I don't remember which experiment, but the TLC and also MP. We will not do the TLC because TLC is your home video, but inside that experiment, the TLC experiment, there are also the MP experiment. MP stand for melting point. So I combine it here in experiment 1C together. So basically we will learn two things. First, how to find the melting point of a substance. Second is how to do a recrystallization. So we start with the first part, identification of unknown using the mixture melting point. So I brief you first. So what we will do is that we have something, this is what we call the capillary tube. I will show you later on the capillary tube. We put our unknown sample inside this capillary tube. Okay, and we insert this capillary tube with the sample, with our sample, into a machine we call the melting point apparatus, and that machine will show us when, not will show us, I mean that we will see through that machine when the sample start to melt. Okay, the melting point is not a point. Remember one thing, the melting point is not a point. It's basically a range. Although it says melting point, it's basically a range. A melting temperature is a temperature when you see your solid start to dissolve until you see the last solid totally dissolve. Okay, I repeat again. The melting temperature is basically the temperature at which the first crystal just start to melt until the temperature at which the last crystal just disappear. I repeat again, the melting point is a temperature at which the first crystal, I mean the solid, just start to melt until the temperature at which the last crystal disappear. You will see through this virtual experiment, I want you to decide when the crystal start to melt, when the everything totally melt. Okay, so you will do the report based on that. Okay, we will show you later on. You will look at that through the what we call, through the machine, and you decide yourself, and then you do the report on that. Okay, so that is what about the melting point, the melting range basically. So you need to have the starting temperature and the end temperature. Okay, so what you do then, indicate your unknown group. So in your lab report, in your not lab report, in your lab manual under experiment 1C, you have these three group 1, group 2, and group 3. So if you look group 1, you have acetylnadylide, butramide, and fluorine. And group 2, you have phthalic, tranexamic acid, and urea. And group 3, you have bromobenzoic acid, benzoic acid, and adipic acid. If you see the melting point on the side, on the right side here, the blue one here, the compound, the group from the group 1 have the melting point which is more or less equivalent. Okay, similarly to group 2 and group 3. Okay, so whenever you have the unknown, first thing you want to do is that you want to see where is your unknown, what we call, lies. Is it in group 1, group 2, or group 3 for this experiment lah. The reason for that is that let's say you get the unknown, your unknown give you melting point 133 to 134, but then you still not sure whether your unknown is cinnamic acid or not, because it's quite near with the phthalic and also urea. Okay, So you need, in order to confirm that, to confirm your unknown is tranexamic acid, you need to combine your unknown with each of substance in group 1, in group 2. For example, the unknown plus phthalate, the unknown plus cinnamic, the unknown plus urea. When you do that, if the mixture contain, for example, cinnamic acid plus the phthalic, the temperature that you will get is totally different. It will not around 130 anymore. It will become lower, maybe like 100, something like that. Okay. For example, if you combine cinnamic and urea, and you test the melting point, the temperature that you get may be like around like 90 or 100. It will not near this 133. So that's what we call the mixed melting point technique. Okay, when you combine two sample which is different, A and B, totally different, you combine together, the melting point will not be the same or near to the melting point of each of them if they are separate. Okay. If they are the same thing, if you combine A and A, of course you get the melting point of A. So that is mixed melting point. I hope you have read the lab manual before this meeting lah. Okay, so that's the first thing lah. So that's the first thing. We will do the experiment later. Okay, so that's number 1. The experiment number 1. Experiment number 2, recrystallization, meaning that this is the technique to purify your material. Okay, so this is the method that we will use. We will like 0.5 salicylic acid. This is just an acid, and then we put into a beaker, and then we melt it. We try to put like hot water inside that. We put hot water inside that. It's not basically heat anti-boil. It's just you pour the water, which is hot water, to the your what we call salicylic acid inside that, and then you will cool to the room temperature. And during the cooling, you will see that the salicylic acid, which is dissolved during the hot temperature, will start to reappear. Okay, and then we filter it and we wait. Okay, along the way during the experiment later on, I will discuss lah, because here I cannot write on this because I don't bring the pen. So normally I just write here, so it's easy for you to see. But yeah, I will explain a little bit further during the experiment. If you have a question during the experimentation later on, you just feel free to interject lah. Okay, if you have the question during the experiment later on, feel free to interject. So everybody clear now? I mean, can you hear me? Actually, can you hear me actually? Because keep quiet. I don't know whether you can hear me or not. Somebody?
Yes, sir.
Okay. So now okay, clear? Clear, I mean the audio.
Yes, sir.
Okay, so now we go to the experiment part. Okay. So now what we want to do first? Okay, we want to do the identification of unknown using using mixture melting point. Okay, let me. Okay, I will zoom first. I don't know this thing. Okay. So here on my sini. Wait. It's difficult. Okay. So you have here. So this is basically what compound in your what we call in your lab manual looks like. Okay, it's just like a solid compound like this. So this one is actinolite. This is from group 1. This is actinolite. This is fluorine, and this is what is this? This is butyremide. Okay, so just for you to see that they are actual compound. When you see the group 1, group 2, group 3, they are actual compound there. In order to do the melting point experiment, you need your compound in a solid form like this. You cannot do using the liquid form, because when you do liquid form, the thing boiling and so on lah. The thing will boil when it reach a certain temperature. We want to see things to melt. That's in melting point. The thing must be solid and dry. Okay, so that is a group number 1. So group number 3 is here. So this is group number 3, group number 2. You have urea, sterlic and tranexamic acid. And you have group number 3 here. There is bromobenzoic acid, benzoic acid and adipic acid. Anyway, during this, when I show this, if let's say you are not clear, I mean the focus is out of, if the image is out of focus or whatever, you tell me, you interject, because I'm not sure what you see over there. I hope you can see. Can you see this thing? Adipic acid.
Yes, sir. I can see it.
Can you see me? Can you see me?
Yes, we can see.
Is it lagging over there?
A bit. Sometimes your voice gets stuck.
Okay, so that's why I will record this video, because from my side it's okay, but along the way, I mean along the internet connection to your side, might be they are lagging. That's why I think it's good for me to record and give like that lah. But still, group number 2, group Tuesday group, you should be, you stay, because this considered as your attendance. Okay, so now we have this 3 group. Let me go down. Okay. Okay, so now we have this 1, 2, 3, 4, 5, 6, 7, 8, 9 sample, group 1, group 2, group 3. And before that, we need to wear the glove. We need to wear the glove. So this is blue glove. Normally you see the white glove. The white glove is latex glove. This blue glove is called the nitrile glove. Normally the nitrile glove is more, what we call, more chemical resistant than the latex glove. Latex glove is okay when you deal with the bacteria and so on. Later on, when you receive the video from the Dr. Raha, you will see that Dr. Raha will use the, what we call, the white glove. Okay, but of course the nitrile glove is much more expensive than the white glove. Okay, enough of that. So let's say you have this unknown. So let's say you have this unknown. Okay, you have this unknown. This unknown. Okay, this unknown come from these 3, either from one of these. Your task now, I mean for your lab report, you need to tell me what is this unknown. Okay, this unknown come from one of these. Your task in the lab report is to show me, to tell me what is this unknown. Okay, so we will do, we will first check the melting point for this unknown. How we do that? We will take out some of it. So I take out. So okay. So basically there are some powder there. So it come from one of these. Okay. So we need to put this unknown into what we call a capillary tube. So this is now this is not tube. Inside that there are capillary tube. So so inside that there are capillary tube. Why we use this capillary tube? Because our machine will we will insert this into our machine lah. Okay, let me zoom a little bit about this capillary tube. If you look this capillary tube, both of it is closed end. Okay, both of it is closed end. Okay, you see kan? You can see kan? I don't know whether it's clear or not, but yeah, I hope it's clear. So both of it is what we call is closed-ended. There are some capillary tube that is open-ended. For example, like this. For example, like this. This is also a capillary tube. But this capillary tube is open-ended. If you see, I don't know whether you can see because yeah. But this is open-ended for both ends. So how you want to put your sample inside this capillary tube? Anyone? How to put your sample inside this closed end tube, and how to put the sample in this open end, both end is open ended. So first we look at this closed end. So how to put it? Zakia?
Immerse the capillary tube with the solution.
Immerse. Why you want to immerse in solution? Okay, first, melting point, as I said before, they have to work with the solid only. So there are no solution involved. And then if you immerse this capillary tube into the solution, remember this is closed. It's like you have this, the straw, the normal straw, but both end is closed. Okay, so simply it's like a straw. It's like a straw, but both end is closed. Okay, there are another capillary tube like this, the blue one here, is like a straw. Both end is open. Okay, so we look at something that is both end is closed. So in order to put your sample inside this, because you need to put your sample inside this, you need to break the thing. You need to break this capillary tube. Okay, you need to break this capillary tube. Okay, before I break that, I will show you the equipment that will be used to what we call to insert this capillary tube. Where is the equipment? Okay, so the equipment is here. I will bring here this here. Okay, okay, you can see. Oh, I put myself up lah. Okay, I go up there. Okay, so this is basically the equipment that you will use to measure the to put your capillary tube in. If you see on top of it, there are like the hole there. So you put your capillary tube inside this. Your sample is inside this capillary tube, and you put inside this hole. And then from this through the eyepiece, you will see what will happening to your sample. And here is the controller. So basically, it's just like when you start whatever. Later on, we will show the temperature will rise, and then through this eyepiece, you will see when the solid start to melt, when the solid totally melt, because you need these 2 points, when it start to melt and when it's totally melt. So now, in order to break this capillary tube, you see there are capillary tube there. In order to break this capillary tube, you need to make sure you break in such a way that it will not short enough. There are many cases of students, they break the capillary tube short enough. For example, they break very short, and then they cannot take out the capillary tube from this machine. And to take it out, the technician need to assemble the entire machine here. So it takes a lot of work lah. So you need to make sure, in order to break this capillary tube, you need to make sure that there are some left over, so that you can take it out later on lah. So how to break that? Is simply you go to the middle there. This you put in your lab report. So you just go to middle, and you just break like that. Yeah, you just break like that. So now you have 2 tube there. So you have 2 tube there. I hope you can see. I hope you can see that. Okay. So now you want to put your sample, the powder sample, the unknown sample, inside this tube. Okay. So that is for the both closed end. Okay, both closed end, and then you break. But if you have something that's like this is like a straw, both end is open. In order, you need to close one of the end. So how to close it? You just take the flame, you open the Bunsen burner, you flame it. Okay, when you flame it, then it will close lah. But we will not do today lah. For that, we just use whatever we just broke just now. Okay, so now let's see how we put our sample inside this thing. Okay, so you have this. Okay, so basically on this thing you have open-ended. You just simply put like that, and then you just need very little. Just put like that. Okay, the amount that you need to put is around like 1 to 2 millimeter, 1 to 2 millimeter height. Okay, 1 to 2 millimeter height. So the reason why I tap like this is that we want to make sure our solid is compact. Okay, because loose solid will cause the heating, will cause the uneven heating lah. Okay, so that's why we need to tap it like this, so that every solid there, you see there are solid there, they are compact they are compact lah. So the heating, when you do heating later on, every part will receive the same heat transfer lah. So that's the reason. So how much you need to put is just enough so that you can see things melt, start to melt and completely melt. So this is okay lah, this amount. You don't need a lot lah. You just put like this amount is more than enough. Okay. So that is our unknown. So now we want to see what is the melting point for this our unknown. Okay. So we bring this over there. We don't need this anymore. So this we put over there. And then we bring our what we call our machine. So this I put here. Okay. I will bring the machine here. And I will zoom it. Okay. And I will take the camera here. I mean me here. I will take this camera to zoom here. And also whatever camera that is seeing this now, I will zoom on this what we call eyepiece, because your task is to see from this. Okay. Okay. So let me open first. So at the back of this there are like a switch, whatever here, switch. So you just open. Okay. So I will zoom this thing, but just to. Okay. So I will take the camera over there and project to this, because we want to see, because you need to see through this, through the eyepiece, and also this, the temperature. Okay, so this is our sample there, the temperature, and through the eyepiece simultaneously. Simultaneously. So let me show you what is inside this first. Okay. Can you see that? Can you see that?
Yes, sir.
Okay. Wait It's because I just use a webcam, so the focus is not really good lah. But I hope you can survive lah. I think. Let me go further first, because this you will do lah yourself. I just said this will take some time. Wait. If you look there, there are. Wait. Okay, wait. I wanted to adjust zoom. Okay, so that is the thing. That is your sample. Will be put inside that. Okay. And then I will take my camera over there and I will show the control panel, because you need the temperature also. Wait. Okay. Okay. Okay, so I will make it this bigger. How to make it bigger? I just bring it down lah. Just bring it down, and then I just want that thing only. And then let me check first. Let me adjust the thing. Mana? Okay, I think you can see the what we call. You can see this. This control panel, and also let me check this. Sorry, we need to take a little bit. Okay, because this webcam doesn't have what we call the what we call the zoom function. So it's just a cheap webcam, so that's why. The most important thing is that you can see whatever I put inside here. Let me, because this is important. Okay. this is the problem with online teaching, because I'm not really you need to set up so that it's clear for you. I mean, if you are in the lab, you can simply see it where your eyes, because your eyes is much more sharper lah. You can see with your eyes. Let me set. Okay. And then put in front. We do lah whatever we can. The problem with this camera, I cannot zoom out. It's just there. Okay, I think that's okay for that camera. This now I want to adjust this camera now, because this is the thing that is the most important lah. Okay, I think that's okay. Just I need to make sure the focus is okay now. So I think that's okay lah kot. I think lah. I need to close the lamp first because there are reflection there. Is it okay? Oh, not yet. Not okay yet. Same je. Doesn't matter lah. I think it's okay lah. Okay, so now, so now I want to insert our capillary tube with the sample inside. If you see, there are three hole there. 1, 2, 3. So let's say I want to put in the middle of the hole. Just now you see there are all hole on top of this machine, right? So I put on hole number 2. Where is the hole? Okay, so you see the sample there, because you need to see the sample. Is it clear from your side?
Yes.
Okay.
Yes, sir.
Okay, let me type first. Okay, so I put your sample here. Okay, so you need to look when is the sample start to melt and when it is completely melt. Okay, maybe it's not very clear to see from your laptop or phone there, but yeah, I think that's the best we can go lah, because there are like reflection there. Even if I close all the light, then there are reflection from this eyepiece alone to the camera, so you cannot do. That's why it's different when you do real stuff in the lab and during the online. It's totally different lah. You cannot beat the experience doing it by your hand, but we manage. Okay, so here, alamak. Okay, that's thing. Okay, so here is your what we call the control panel. So now it's in ambient temperature, which is at 28.2. So this thing, whatever you see in front of you now, we call it melting point apparatus. Okay, melting point apparatus. Okay. So here, first thing what you do, the store sample, the bottom button here, nothing lah. It just store sample. It's just like storing whatever lah. The most important is the top one. There are mode, there are start, and also there are stop. So now the temperature is 28.3. So if you go to mode here, you will see the plateau there. The plateau 60 Celsius. What is plateau? Plateau mean is that when you press start, the machine will start to ramp their temperature very fast until it reach the plateau, until 60 Celsius. And then it will stop. It will give the sound and it will stop there. It will stop there. and then, so that's what does it mean by plateau. Fast heating until it reach the plateau. Okay, and then if you press the mode again, you see the slope 5 degrees Celsius per minute. What does it mean? If that after the plateau is reached, if you start again, your temperature will rise slowly by the rate of 5 Celsius per minute. Okay, maybe from the ambient temperature to the plateau, the rate of heating will be very fast, maybe 20 Celsius per minute and so on. But then after it reach plateau and you start again, the heat will ramp up very slowly, 5 Celsius per minute, like that, until you stop. Okay, this machine can go until 300 Celsius. Okay, so it will continue heating, ramping up 5 Celsius per minute until it reach until you stop lah. Okay, and then this is the stop button, and if you press the mode again, you see it coming back to the original lah, the ambient. Okay, so if you look here, where is the thing? Wait, I need to. Where is my? Okay, if you look at your our plan here, our what we call our sample melting point is above 100. It's more or less above 100, and our unknown is coming from one of these, either one. So if our plateau is 60, and then from 60 to reach to 100, whatever, what is the lowest, 113, it takes a lot of time. So that's the reason why we will what we call, mana? Wait, where is my mouse? Okay, that's why we want to change our plateau here. Our plateau here, instead of going to 60, we want our plateau around like 90, like that. Okay, so how to change it? We just press it for a while. No, we just no. I also don't remember this, but I think you just you just press it. So we will go for like 90, like that, because that is nearer, so you don't need to wait lah. 90, maybe 100, maybe we go 100 lah. Maybe we go 100, because we know the nearest sample, because we know our nearest sample, our earliest melting point is 113. Okay, so by 100 we can save time lah. Okay, so from now on, I want you, and the slope we maintain 5 Celsius per minute. This you need to what we call to record, because this is your lab report. You need to record all this. It's not in your lab manual. You need to record this, and then this cooling. So now we will start. So our plateau 100 now. Our slope is 5 Celsius per minute, and this ambient. So now we will start. Okay, so we will start now. Your task now, you see, is heating. So now it's heating very fast until 100. And not really fast too much lah, but it's pretty fast. Your task now, each of you in a group, remember, know your group member, because you will do your lab report based on group. Your task now is to look in this through this eyepiece when this the white stuff there start to melt. Record the temperature, and when it totally melt, record the temperature. Okay, so that's your task. There are some reflection there, but this is the best lah I can do. So for now, the temperature will go fast, up to 100, and we know our sample will not melt at 100, because all our sample will melt above 100. So for timing is okay. So any question now for timing? Any question? Why we waiting until 100 now? Zalika?
Yes, sir.
okay? Can you see clearly the what we call the sample there inside there? Because I don't know whether you can see or not the sample. I saw they are reflection, right? But I think you can see.
Oh yes, there are some reflection.
Yeah, cannot do anything about that because but at least you can somehow see. Let me zoom a little bit there. For time being, we are not okay because we know our sample will not melt until 100 plus, so it's okay. But if let's say you don't know the group, here if you look here, you already know our unknown is coming from one of these. But if let's say you are receiving unknown from somewhere else, then you don't know when it will melt. So from that purpose, you need to start your plateau below lah. But for this experiment purpose, it's okay because you already know all your sample is either from this 9 entity lah. Okay, so let's go back for this. Let me zoom a little bit whether it can give a good image or not. Yeah, I think that's better. We just want to see the middle only. Yeah. Okay, now it slowly reaching 100, and you will hear a sound at 100. Okay, you will hear the beep sound at 100. Everybody at home? Anyone still in UAE? No one. Okay, so you hear that sound, tit, tit, tit. So meaning that it's really, it already reached the plateau. If you look here, they are already steady here. Okay, so now it's up to us to start or to stop. To start or stop. When we stop, meaning that it goes back to the ambient. When we start, it will ramp up until it's reached 300 Celsius lah. Okay, so now this is where I want you to look at this eyepiece to look when it will melt and when it's totally melt. Okay, the first instant you see the what we call the crystal melt, jot the temperature, note down the temperature, and when all totally melt, jot down the temperature. So I will go start now. So now it's ramping 5 Celsius per minute. Is it ramping? Yeah, it's ramping. So that's 5 Celsius per minute. Okay, while you see this, you need to take close look lah on that. While you look through the eyepiece, I will prepare the mixture. If you have any question, you can just shoot the question to me. A question about the experiment, not about other thing. For example, when it's to submit, question about the experiment itself. The other question you ask after the end of the experiment. For now on, if you have a question related to the experiment, then it's okay. Please observe. In the lab, if you are physically in the lab, you will start in front of the machine until it's melt. Okay. It's the same thing. If you are in the lab, you need to look through the eyepiece until it melt. But what worse is that during the physical time, you need to also see the temperature while looking at the eyepiece. But here you can see side by side. Okay, if you see it's already melted, I mean the entire thing is already melted. So you need to note down when it start to melt and when it's totally melted like this. Okay, so now put that temperature range in your note or whatever, because that is for your lab report later on. So now we're done with this. I will show you now. So we're done with this. The most important, you need to press stop, because if not, the temperature will run until 300. Okay. One of the problem with this machine is that to heat up is okay, but to cool down is cool down what we call manually, meaning that there are no fan whatever. It depend on the surrounding atmosphere. So from 199 to go down to ambient, it will take time. It will take time. Okay, that's why I will use another machine here later on. The reason why you need to wait for it to cool is that if let's say now, okay, if you look here, now you see your sample in what group? Your sample now
Group 1.
Group 1, right? So group 1 you have acetamide, butramide and fluorine. So now in order to ensure what is your sample, because even though you may think it's sure it is something, but the temperature here in group 1 is more or less same. So you need, in order to be sure which one is which one is your unknown, is that you need to mix your unknown with one of the sample, each of this acetamide you need to what we call mix with the acetamide, mix with butramide and mix the fluorine. If two mixture is different mixture, then the temperature will become, the temperature where they melt will become very low lah, lower than 100, lower, I mean maybe 100, but will not reach this melting point lah, will not reach melting point for each of them. The reason for that, that's you need to discuss in your discussion part in your lab report. Okay, so now we have our unknown. We will mix this acetamide, butramide and fluorine, and then we will put inside this what we call inside the melting point apparatus. Okay, the reason why we need during the class, if this is a physical class, each group have their own what we call own melting apparatus, and you need to wait until it goes down cool enough. For example, maybe 50 Celsius like that. The reason is that if let's say you mix and then you put your sample inside at 108 like that, maybe your sample already melt. You put is straight away melt. So you don't know when it start to melt, when it's totally melt, because you want to find the melting point. So that's the reason you need to wait this to go down lah. But to save time, I've used different machine lah, different machine. So I will mix these two mixture. So for that I already have the thing. Where is the thing? So this. So for that I already have these three. If you look here, I have already three. This I already mix. After this I will show how to mix it. But basically these three I already mix our unknown with one with each of the group 1 substance. So this mixture of all them. Okay, I don't know which one is which. So I will take the new machine and put it here. So I will put it somewhere there. Wait. Okay, this is new machine. Okay, so you see, that is the hole. That's the hole. That's the hole that I tell you. So that sini. Okay, so I will open here. So I will open the machine so you don't see anything. Okay, I hope you can see there. Okay, because we will do 3 simultaneously, so you need to see all 3 hole. Okay, so I think that's okay. This is not okay. This is not okay. Let's see here. Okay, the same machine but different machine. Where is my sample? Here. Okay, now I have these 3 sample now. So I will tap first. So now you need to see, wait, I will tap first so that it's compact. Okay, so I will put one in the middle. Okay, one in the middle. So you see the sample there. I will put one on the left. So you see the sample there, and I put another one to the right. Okay, sometimes you cannot insert this because some of the student broke the glass inside. You need to put it slowly, because if you handle very, if you force the capillary tube inside this hole, sometimes it will broke. The glass will break lah, and when the glass will break, the technician need to open the entire thing again lah. So bear that in mind. That is in the precaution. In your lab report, you need to tell also at the discussion part, you need to tell what is the precaution during the experimentation. So that's one of the precaution lah. So you have 3 sample now. This and the middle there and here. Okay. So now as usual, we go to mode and the plateau. Okay, here let's say, okay, we can put plateau 90 lah. I think 90 is okay good. But be careful lah, you cannot put like 100 or 100 something, because we know when you mix 2 different things, the temperature will be what we call depressed, meaning that the temperature when it melt will be lower than the temperature that it is actually melt if they are individual. Okay, so you need to put the plateau maybe like 80 like that. So let's say we go to plateau, we don't want start at 60 because it takes a lot of time. Maybe 85 I think. 85, okay, 85 I think it's okay lah, 85. Okay. Don't put the plateau too high here, because now you don't know which one is which. You mix thing together. Previously it's okay. You put like 90 or 100 because you know your sample will melt above 100. But now because you already mixed, you're not sure. Even though all of them, as I said before, this is the idea behind this mixed melting point. the idea is that even though you see 100 here, if you mix two together, the temperature of the melting will be lower. So that's why we put our this 85 is okay. So then we start. No, yet we go to mode gain, slope okay, cooling okay, and then we start. So it will hit like previously until 85. Okay, if you look here, the experiment is quite straightforward. But during the physical lab, this is the longest experiment. I mean, not the longest, I mean the most boring experiment. The student need to wait. Okay. As I said before, when you are in the lab, there are many groups, and we only have a few instrument, few melting point instrument. And you need to understand, when you hit something, and then when you cool it down, the cooling happen not forced, meaning that it will cool slowly. The student need to wait until it's cool enough in order to start the next mixture melting point experiment. So that's why typically when you are in the lab, this type of experiment 1C, the student will normally going back home maybe like 30 minutes or 1 hour after 3 hours, because lab itself is 3 hours, but then because of this waiting game, you cannot do anything. So student end up going back ni lah, later. But here I'm using the two instruments simultaneously, so that speed up the thing lah. If not, you need to wait long. What we do now is what we call mixed melting point experiment. We mix two different substances and we do we find its melting point. Okay. Basically, most of the solid like this, most of the solid in the lab that you find in the lab are crystalline. We call it crystalline solid. Okay. And these have the molecule, crystalline mean that the molecule of it is repeating, it have a molecule of repeating cluster or ion arranged in what we call the regular or tightly pattern lah. I mean the atom inside this powder is quite ordered. Okay. So that order is held together by the various intermolecular force lah. Okay. In order to disrupt that force, okay, in order for it to melt, you need to disrupt that force, the intermolecular force between this atom lah. So which require the input of energy. Okay, this input of energy is basically translate to the evaluated temperature that you see lah when it melts. The stronger the force, between this solid, the higher will be the melting point. Okay, so that's the idea between the melting point lah. Okay, when you mix together two different solid, okay, the foreign, I mean the impurity, we call it impurity substance in a crystalline solid will disrupt the repeating pattern of this crystal lah. Okay, so then it require the smaller amount of energy to melt it. Okay, because part of the crystal, the pattern is surrounded by the impurities. The intermolecular force between them will not be strong enough lah. So now we already reached the plateau part, so we go start. So now it's your time to look through the eyepiece here and see when it start to melt and when it is completely melt. Note down the temperature in your notes for your lab report. Okay. Note down all the temperature, the range for all these three. So it's already 9:30. Yeah. Maybe another like 15 to 20 minutes because after this we will see the recrystallization. There are 2 experiments today. So we go beyond 1 hour. Still okay because a real lab it will take around like 3 hours and plus. But now I'm compressed it to like 1 hour and maybe 1 hour and a half like that. I think it's okay for you. By the way, the most important thing in your lab report is the discussion part. The discussion part. Okay? Because if you see the mark on the discussion is much higher than the other component. The mark in the discussion part is much higher than whatever in the component part. Okay, so you look at that. So just observe through the eyepiece. Later I will tell you which one is I make which one. So one is already melt. So now it seems there are another sample melted, but we need to know what is our unknown. We know at the first experiment before, the first test of our unknown melt at this certain temperature. So you need to make sure that your whatever left now will melt at that temperature. So then you be sure that your unknown is that stuff lah. So I think I will not tell you what is this, and what is this, because you have the melting point for your unknown, and from this, without I'm telling you what is this, you will know what is your unknown. So you discuss lah. You discuss in your, you tell me in your lab report what is possible mixture of this, what is possible mixture of this, and what is the possible mixture of this. Okay. So we wait until everything melted, because it is in group 1, so it will not take long time, because the highest will be less than 120. So everything in the group 1 less than 120. So if you see now, everything is already melted. So I hope by now you know what is your unknown. So you need to jot down, give your answer in your lab report. Okay, and also not only that, you need to tell me what is the possible mixture of this, what is the possible mixture of this, what is the possible mixture of this. So meaning that you can basically later on when I give you a video, you can take a picture for this this part, and then tell me what is this, what is this, what is this, a possible mixture for this, this and this, and then we stop. So we stop. Okay, so that basically the melting point technique, mixed melting point techniques. So I will open the lamp first. It's quite dark here. Okay. So any question now? Any question for this? Before we end this part, there are another part, but that another part is quite fast. Any question? Khadijah? Or Farhan?
No. No, sir, no.
I just want to check whether you are still here or not. Okay, one thing about the when you melt, you cannot, if let's say you take it out, okay, let's say I take this is from another the one that we do early on, the one that's melted early on, the unknown. If you see, the thing is already become solid again. It's not. Yeah, it's already solid again. Solid again. So you cannot use this to check the melting point again, because the reason for that is that maybe when it's melt just now, I mean at the beginning when we test our unknown here, maybe during the melting, it's already undergo the chemical change or decomposition. So if you try to put back inside this melting point apparatus, maybe the melting point will not be the same as previously. Okay, so always use the fresh sample, not reuse the old sample. So that's the idea. So if let's say I wait this until the end, I will wait, if let's say we wait until the temperature equilibrate at the room temperature, all this liquid will turn to solid again like this. Okay. Anyway, that is basically melting point techniques. But before we go, so I will bring this, I will put it back there because we will use another thing. Okay, one more thing about this equipment. You cannot just switch off. You cannot just switch off this equipment. Okay, let me take it out lah. So I think this done. So I just bring this So done. So this I done this. I will bring this over there. Yeah. Wait, it's so difficult. So it's not quite okay. I think. Where is the thing? Yeah. Okay. Later I will change the mirror. So basically, okay, we resume again. Resume out. So this I want to make it small. How to make it small? Okay, I want to make it myself small. So I make it small. So this will be myself lah. This myself there. It's okay. I will adjust later. But this, because we're done with this thing. Okay. So it's pretty difficult because I only have the webcam, so cannot really focus very well. But I hope. So I want to adjust what we call this thing, this camera first. Wait. Okay, I think that's okay. Good. Okay, I think that's okay. So you can see me. Still, but it's okay lah. Let me put this thing. So let me put there. It's quite difficult if you are doing it alone, because I need to control this thing, and then is it okay? Or I will be there. Okay, I think that's okay lah. So I bring this back. I think myself back bottom and make it smaller, and I put here lah. I put myself bottom there. Okay. Okay. So now that is what we call the mixed melting point experiment. So I put this. We don't off yet because you need to wait until it's reached to the ambient temperature before you off this equipment. Because if you off it now, then it will damage whatever this thing lah. That what technician said lah. So I will put here before we do the next experiment. Okay. So this is not here. Okay, so now before we go to the next experiment, I want to show you how to mix the stuff. Because this is important in terms of precaution. Let's say this is your unknown. And then where is my unknown? Okay, let's say this is our unknown. Let's say this is our unknown. In order to mix the stuff, let me put here. Okay, let me zoom a little bit. Okay, in order to mix your stuff, you take your unknown just now. You just take it and put it, and then when you want to mix with your another unknown, let's say this another unknown, you need to make sure you clean this. Many students doesn't clean this. Because if you don't clean this and then you use the same spatula for this unknown and also for this known sample, then there will be impurities for the unknown into the sample and it will damage the entire sample lah. This will not be pure. So you wash and whatever, so you can use this also, whatever. So basically you need to make sure that, okay, this is very important, which many students overlook. Okay, and then you cannot mix like this. You take this, you cannot put somewhere else. Let's say I put here. This is your, I don't know whether you can see or not there. I hope you can see. No, you cannot see. Let's say
No, sir, we cannot see.
Yeah, I know. This is white on white. So let's say I take this lah. Let's say I take this black thing. And normally you put on the filter paper. But let's say for this demonstration purpose, I put on this black thing lah. Let's say now I have this unknown. Let's say this unknown. I don't know this and then I put some of it on this. Let's say on this, and then you have the another one. This is your known sample. Let's say this is your known sample. Make sure you clean this first, and then you cannot just put somewhere else and then take your capillary. Where is my capillary? Let's say this capillary. Let's say this is your capillary. You cannot just put this and then you tap it and then you put this together. You cannot do like that, because now your unknown will be at the bottom and your sample, the known sample, will be on the top of the unknown. And when that happen, you will see the heat distribution will be not true lah, will be happen differently. So in order to do it correctly, is that you need to take your what we call your known sample, mix with your unknown sample together on top of that, and then mix thoroughly like that, blah 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 blah, and then you put on this thing, and then you do whatever we did before. So that's basically how to what we call mix your unknown and known mixture. Okay, so that's done for this part. So now let's do the second part, the recrystallization part. So we put there over there. The recrystallization part is quite quick lah. You're not waiting like just now. So what we do? So recrystallization. Okay, so you have this. This is basically salicylic acid. This is salicylic acid. Okay, you have this. It's just like a solid acid. Okay, it's just like a powder there. It's just like a powder. So you see that's just a powder. So we want to purify this. This alone is already purified. Okay, this already pure. But we want to see what will happen if we try to recrystallize this powder. What will happen? Okay. So the plan is like this. As you see before, the plan is that you have whatever you take 0.5 gram or 0.2 or 0.5 gram of that acid, and then you put it into a flask, and then after that you add the water. You add the hot water. You don't put water first and then you boil. This is quite wrong here. You add the hot water, because the reason is that, because why you don't want to boil the thing is that when you boil, your sample will be here and there lah, splash here and there. Okay. The idea for this recrystallization is that you need to find the solvent, in this case the water or whatever solvent, that can dissolve your sample at hot temperature but not dissolve it at the room temperature. I repeat, the idea for the recrystallization is that you need to find a solvent that can dissolve your sample at hot temperature but not dissolve it at the room temperature. Okay. So it's not like you take the sugar, put in the water, because if you take sugar and put in the water, at room temperature it already dissolved. Okay, at hot temperature it's also dissolved. So you cannot recrystallize the what we call the sugar using water. You can recrystallize using another solvent, another, not water lah. But in this case we use the salicylic acid. The salicylic acid that we will use, this salicylic acid that we will use here, will not dissolve when you have the normal water. For example, let's say you have this beaker and then I put it inside this thing. So let's say I put this thing in that, and then let's say I add the water there. So from this, alamak, wait okay, from this, if I put the water there, if I put the water inside that, you will see that this thing, this salicylic acid, okay, this salicylic acid, so I hope you can see that, you will see that the salicylic acid will not dissolve at room temperature, even though you swirl or whatever, you will see it will not dissolve this at room temperature. Okay, so that what does it mean by it not dissolve at room temperature? But if I heat this, it will dissolve. Okay, something like sugar, like salt in your kitchen is different. They dissolve at room temperature, and also it dissolve at hot temperature. But this case is different. It not dissolve at room temperature, but it dissolve at hot temperature, and when we cool down, it's not dissolve again. So the way what we do is that, let's say we take this this thing. Let's say I take this. This is what we call the hot plate. Let me zoom out first. So this is hot plate. This is basically a hot plate. Okay, what we do is that we can open this, so it's heating. Okay, we can do like this. We cannot do like this, because if we try to what we call heat it straight away like this, when it's boiled, the undissolved they will be splashing to the side of this flask, and then when it's splashed to the side of the flask is cooler than whatever inside the solution. So when it's cool, the thing will your sample will be adhere to the side. So the correct way is basically you put your sample inside the flask, and then you pour in the hot water to the sample. Okay, for that I already this is quite a lot of wire. Okay, so here is example of hot water. Let me, okay, so that's hot water. This is what we don't want. We don't want to do like this. So we take a new flask now. We take a new flask. So we have a new flask here. So a new flask, and then we take our salicylic sample. So this is our sample, our sample. Oh, this white and white. So that's why you can so that sample. So we put our sample inside the flask. Okay, done. Okay, so what we do now is that we add this hot water. This is hot water, so I think you see this like this. That's easy. Like that. That's easy. So you take that hot water, put inside this, and if you look at this our plan, we will put around 15 ml of hot water there. This is what our plan. So we will use this pipette. We will use this pipette. This 10 ml pipette. Normally you don't see this in our lab. Okay, because this 10 ml pipette is quite rare lah. Okay. Normally you see 1 ml pipette, but in order to put 15 ml, you need to do it 15 times. Okay. So now this 10 ml pipette, during Dr. Rahat time you don't see this, but basically the idea is that it's same pipette but it's 10 ml lah. So this is the what we call the tips for this pipette. You see that's quite big lah. Okay, so basically we just put like that, and then we set into 10 ml first. So I don't know whether this is clear or not for you, but I hope it's clear. So 10 ml. So how you do it is basically, in order to put this into this, you need to wait. Let me put high like that. You need to make sure you hold the pipette very straight, like this. And then you put, and you take some. Okay, so because it's boiling, so we need to, okay, slowly we pull out the, because this is boiling, so that's the problem. We need to stop the boiling first. Okay. Normally you don't pipette the thing which is boiling because there are like a pressure there, and the pressure will go inside this thing. But because this is water, that's okay lah. But if this is another solvent, be careful lah. You don't use this, because when you boil something, there are some pressure out. There are like vapor out, so the vapor will go inside the pipette. Because this is water, then I think it's okay. And this is by pipette anyway. So you just take it out, and then, oh, this is hot. Okay, this is not. Okay, let's say this thing lah. Let's say lah. Okay, so let's say I put this. Okay, and then let's say I put just like roughly 15 ml. Okay, roughly 15 ml. Okay, so now done with that. So, okay. So if you look here, let me I bring myself up again. Put myself up again. Okay, if you look here, so now what you do is that you try to swirl down slowly and slowly. If you look here, there are no more salicylic acid there. Compare this with this. This is what we do just now without heating. So there are some salicylic acid there. You see there are some salicylic acid without heating. But in this case, we basically pour the hot water there on the salicylic acid, and you see which is hot. Okay, so hot. So be careful, huh? So the thing is dissolved during hot. This is what we want. We want for recrystallization, it dissolved during hot, but it not dissolved during cold. That's what we want. Okay, and the key for recrystallization is to find that solvent. In this case, for the salicylic acid, we are fortunate because the water can do that. Okay, now when we done that, so we see there are no more. So you look here, there are no more. So let me zoom. So we try not to do anti-spoiling. So I think that's okay. So now once it's done, what we do, we take it out. What we do now, once we're done, we take this and put on the table, on the bench. Can I see that? Okay. Wait, you cannot see there, but let me take this. Okay, and then try to see what happened. I don't know, you can see or not. Wait. Okay. I should basically heat it until everything is dissolved, but it's okay. So at least you can see. So see what happened. Now we cool it slowly. So there are two ways to cool this. Either you put on the ice bath or you cool it like this, meaning that you put it on the room temperature. So look what will happen. They are different when you cool like this. When you cool like this, and when you put this stuff into the water bath, ice bath, something cold. Later we will show what happened. So now you look something happening there. So you see Frozen, movie Frozen. So that's what happened. So what happening now is that you will see a sharp needle appearing. So that's basically the salicylic acid atom. They try to rearrange themselves in an order. That's why you see. Oh yeah. That's why you see the sharp needle there. Okay. If you look, if you see the crystal, the term crystal itself, if you see the crystal, it has some definite structure, long and sharp at the end. So this is the crystal for salicylic acid. So you see it's formed like a sharp needle there. Okay. So basically so if you look closely, so that's what happened. So now let us see what happened if we cool this thing very fast, meaning that we put this instead of put on this what we call on this. So you see crystal So take this picture later on. You take this picture. I bring it out. Okay. So for your lab report, take this picture. Take this picture. During the movie, take this on my video. Take this picture and discuss. I bring myself. Okay. So now let's look what happened if we cool down, not like this at the ambient temperature, but we put on the ice. So let's say we do it another one. So you know the drill. So I bring myself here back. So let's say I already prepared that. So I have this, and then I already have this thing. I already have So I already have this, the sample, and then I just put inside. So the same idea before, and then I take the pipette, you know the pipette, and then I pipette there the hot water, and then you put there. The same idea. Let's say it's 15, so I roughly, even though I set to 10, but roughly let's say this is 15. Okay. So the same thing, and we try to swirl down until it's dissolved. And while this is dissolving, I will take the ice from the next lab. I will take the ice, so I will let this to dissolve for a while. But while doing that, I will take some ice in the next lab. I think you can still hear me. So the idea is that when you put ice, when you use ice as the cooling medium, it is basically when you have enough doesn't have enough time to recrystallize, and you see a little. Wait, I take that. So this is in the lab. Then that's it lah. Okay, so I put here. Okay, so that is the ice. Okay, so that's the ice. So now, okay, is it already there or not? Okay, it's okay. Okay, so now when you have ice bars, when you have the ice bars, okay, if you look here, I said cool to room temperature using the ice bars. So this is just the ice bars. So this is the ice. So you don't put your sample inside the ice like that. Okay, you need to put water inside this, because if you just put like this, even though it's cold, there are less contact between this ice thing with the flask surface. So you need to put the water in order to increase the contact between the flask surface and also the cold medium. So you just add water. So I have this water, and then I just pour lah. Just pour. Pour. Okay. Okay. So now I will put our sample over there. That sample I will put inside. Okay. So this already that. So we will see the difference. What is the? So this basically what we do now is basically fast cooling. Fast cooling. We call it fast cooling. So I need to hold this because if I not hold, yeah, it's okay. Okay, so let me zoom the thing. Okay, let me zoom the stuff and blah 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 blah. No, yeah. Okay, let me zoom. Oi. So that's why you need to hold. In the lab, you have your friend to do this, to help you. But now I'm alone, so it's quite tough actually to do this, to control the computer and that thing. But yeah, finish. So you see the structure is a little bit different there. There are some needle, but it's more like not a definite structure. They are more like a robust structure like that. I mean, more hairy structure like that. I cannot focus it because this is the best focus I can do with my webcam. So the reason for this is that the salicylic acid inside the hot solution doesn't have enough time to rearrange themselves so that it become like nice structure like the needle structure like we see before. Before we see the nice structure, before we see this nice structure, okay, that nice structure there is because the acid have time to rearrange themselves. Okay, this is fast, what we call fast, when you do a fast cooling. So I will remove this myself, and for your lab report, take this picture in the video recording, take this clip picture and then discuss. Okay, so that I bring myself again. Okay, so basically we are done with that. So the last part now is that we want to filter this out. The last part for this experiment, we want to filter this out. Wait. Okay, so just another like 5 minutes and then we're done with this. Another 5 minutes. So we take out there, bring there, bring there. That's down. So now what we do is that, okay, so now what we'll do is that we will filter whatever that we have now. For example, this is our needle stuff there. We want to filter this. The reason why we want to filter this, we want to take out the needle, okay, and then to weight it. To weigh the weight of the needle itself. Okay. To filter that, we will use this. This is a vacuum filter, vacuum pump. This vacuum pump, and then to filter that, we will use this thing. We will use this buncher funnel. Okay, buncher funnel. Okay. Let's say we have. Let's say we have this filter paper, so we will use the filter paper, okay, but this filter paper is bigger than that, so you need to cut this down lah. Okay, so you need to cut this down. So on the every bunch of funnel, they are like the numbering. So here they said 50 mm. I don't know whether you can see or not, but I hope you can see. But if you don't see, just imagine this is 50 mm. So the diameter of the 50 mm meaning that the diameter of the inside. So you need to do that. So to do that, you can just take this whatever that thing, and then you can just do the thing lah. And then take the whatever the ruler, and then go to, because 50 mm 5 cm, so the radius is 2.5. So take 2.5 like that. So and then you just do like that. So make the thing. And then you cut it, okay, and then you make that, and then you cut it like this, okay, just simple cut like that. I hope that's clear there. Okay, when you cut the filter paper for buncher funnel, one tips that you can do is that you make this, the ear, telinga, okay, make telinga like that, okay. The reason for this, for you to make an ear like this, is that easy for you to take out, okay. Sometimes if you cut it round like that, you cannot take it out. It's very difficult to take it out lah. And then you put on top of that. Okay. If you see here, if I put on top of this bunch of funnel, you see it's like moving here and there. It's not fit. It's okay. as long as it's cover all the what we call all the hole. That's the most important. Okay, and then we use this. This is what we call filtration flask. Filtration flask. And we put that and we put inside here. Okay, the reason why it's okay to do like this is because when you add water, it will fix the position. As long as the hole is covered, then it's okay. Okay, and then we will pass this what we call to this this nozzle lah. Yeah, that nozzle lah we call. And then we can on the pump. Okay. So the key when using a filtration or buncher funnel is that you must wet this thing first lah. Wet this thing first, so that your filter paper is stick on the thing, not moving there. So now you have, let's say we take, where is my? So let's say I have this. This is your what we call your needle stuff. See, there are needle there. So I put there. The reason why we want to do this filtration is that, let's say, before this, let's say I weigh this, let's say 3 gram. Let's say 3 gram, and then I put in the flask, and then I do the recrystallization. If let's say the weight of this, the weight of our original is not the same of the weight of the whatever you got after this, then you know that there are some impurity there. So that's the reason. Okay. So now, so let's say I swirl down and then just put it slowly. Slowly. So you see there are something, I don't know whether you can see or not, but it's okay. Blah blah blah, and then you can just put water, because remember our sample, our salicylic sample is not dissolved in the room temperature. So that's why it's okay you put water there, because it's not will dissolve anyway. Okay, so you go like that. So whatever. Let's say done, habis, finish. And then you close this, and then if you take it out, you see there. Where clear or not? I don't know whether it's clear or not. Clear or not? Not clear. I don't know. But I don't know, because there are no focus there. Wait, let me check. Let me zoom. Okay, so you see, if let's say the weight of this is not same as the weight that I previously put when I start this, then you will be sure that there are some impurity there. Okay, so in your lab report, just make some value lah, just what we call, put some value of the original, and also put some value what you weight later lah. So at the end of the day, let's say at the end of the day, you will get something like this. Okay, so you get something like this. So this, okay, you have, I don't know whether it's clear or not. So let me remove the zoom out a little bit. Okay, so you got these two. Okay, like that. I hope it's clear. I don't know, it's not clear because this is just I put in water lah. So I think I just put on this lah. So this, you will see, this is with the quick cooling. This is fast. This is using ice. This is not using ice. So you see, this is a little bit different lah. I mean, this is just what we did just now. Okay. So you see, there are, I don't know, this is not clear lah. I don't have good. Okay, so this, you take this picture and then you discuss in your lab report. Why this on the right, they have like a clumpy, not clumpy, like it's not like a needle form, but on the left here, this left is basically it's like a needle form like this. It's like a needle. Actually, it's difficult to see from this because of the light. But anyway, this is a needle form. This is not like a needle. It's like a small needle only. But this is a long needle. Okay. So basically, in your lab report, take this picture. So take this picture, and discuss why this is needle form, why this is not needle form, and also discuss what if the weight of this is not the same as the beginning. You can make your own value lah. So that's it, basically that's it for today's experiment. Where is myself? Where is me? Oh, I don't know where I put myself. Oh, I don't know where is me. It's okay lah. Oh, this is me. Okay. So that's it for today. Any question? So that's it for today's experiment. So experiment 1C, B102184. So this is what we do today. We learn about how to find the mixture melting point, and mixture melting point, and then the second we learn about the recrystallization of an acid. So that's it for today lah. So any question? Okay. So any question? So that's the end for today's session lah. So any question before we left? Anyone? So it takes around 1 hour and 45 minutes. 10-15. 1 hour and 45 minutes. Yeah. Yeah, that's better than 3 hours. What to do? So any question before we end this thing?
No, sir.
No, okay. So make your lab report based on this, based on the experiment that you just see. Okay. For melting point, you know what to do. For the recrystallization, come up with your own numbers and then discuss. Okay. So lab report, what we call, submit for the Tuesday group. Submit next Tuesday. No lah. I think you submit in next Tuesday lah, because easy for me to differentiate. So for the Tuesday group, submit on next Tuesday. I will open the Google Classroom folder where you can submit. And for Thursday group, I will prepare the video, and then this video I will copy this recording and make a video, and then I will put on the Google Classroom or in the WhatsApp later on. Okay, so for the Tuesday group, Tuesday next week, submit your lab report, type, and then for the Thursday group, wait until I give the video. So this is a group work. Lab report is a group work, and follow the format and so on. And I think that's it for today. So if there are no question, I think that's it. No question, So no. So we end our class with recitation of Tasbih Kafarah and Suratul As. Okay, that's it, and sorry taking a lot of time.